8.1 covers the law of sines. The law of sines from your at-home notes shows the formula for the law of sines. You can also write it this way. You see it either way in different books, and it's nice to have both ways. Can make some problems easier to solve if you have it this way or if you have it this way. So basically, the law of sines, you're only going to be using two of the fractions at a time. It says that the ratio of the length of the side of any triangle to the sine of the angle opposite that side is the same for all three sides of the triangle. So you're able to set up a proportion this way. Let's try this on a problem here. Determine the remaining sides and angles of each triangle ABC. I have a couple of examples here. A is easy to figure out. We know that the sum of the angles is 180, so we're just going to subtract the 52 and the 29, and we get 99. All right, so A is 99 degrees, and we have little a already. It's 43 centimeters, so we need to get little b and little c. So little b is over sine of the big B, the angle that's across from it. And since I have both the angle and the side measurements here, I can set that for my other parts. So this will be 43 over the sine of 99 degrees. And now all I have to do is multiply by sine of 52 degrees in order to get B by itself. So B is 43 sine of 52 degrees divided by the sine of 99 degrees. And we'll get an approximation this way. And you have 43 times the sine of 52. Make sure and close that argument. Divided by the sine of 99. Close that argument, and we get about 34. They put this into the nearest whole centimeter, so let's go ahead and do that with this as well. So B is approximately 34 centimeters. Don't forget your label. Right, so we can do the same thing with C. C over the sine of the angle that's across from it is equal to 43 over the sine of 99 degrees. Okay, you could just as well use angle B and side little b, but we did have to approximate. So if you use that, make sure that you use this number in your calculator so you have less round off error there. So I'm going to multiply both sides by sine of 29 degrees to get little c by itself, and 43 times the sine of 29 degrees divided by the sine of 99 degrees. And we get approximately, we'll say, we get approximately 21 centimeters. So you have basically solved that triangle. All right, the second example, same type of thing, but you have a triangle that you haven't determined what it looks like. So just make a quick drawing. Okay, big A is 35.3 degrees. Big B is 52.8 degrees. So we need to know what big C is. They're telling us what AC is. That's little b. That's 675. So we need to know what little a and little c are. These are the things that we'll be trying to solve for. Again, big C is easy to find. And we just subtract the other angles there from it, from 180, and I get 91.9. And that's my degrees. And little a is over here. Okay, so we're going to say a over the sine of 35.3 degrees is equal to 675 over the sine of 52.8 degrees. We're going to multiply both sides by sine of 35.3 degrees to get a by itself. So that's 675 times the sine 35.3 degrees divided by the sine of 52.8 degrees. So 675 times the sine of 35.3, close the argument, divided by the sine of 52.8, close the argument, and I get about 490, and our label is feet. And for C, we're going to end up with the same type of process. So little c over the sine of 91.9 degrees is equal to, let's use our B, 675, just like we did before. Just trying to avoid any round off error. 75 times the sine, 91.9 degrees, over sine 52.8 degrees. So 675 times the sine of 91.9 divided by the sine of 52.8, and I get approximately 847 feet. All right, so it looks like we've solved that triangle there. All right, now we're going to get into some cases where you have to be very careful. You have to be careful when you have a side-side angle triangle. This is the ambiguous case, and this is when if you're going around a triangle with looking at the given information, that you have the measure of this side, okay? You have the measure of this side, and then coming around, you don't know what this angle is, but you have the measurement of this side, and you're going around here and you do know what this angle is. So these are the three things that you have. You have a side, and an angle. When that happens, because of the way this can move and the way this leg, we don't know what measurement it is, this side, then you have the possibility of having one, two, or even no triangles. So let's get into those different cases here. First, we go ahead and draw our triangle. It does not have to be to scale. Don't feel like you have to try and do a perfect mock-up. You really just are using your drawing to get all the pieces in the right places. You're getting oriented. And this is big C and little c. We are solving the triangle if possible. Okay, so looks like we're going to be using big B and little b and finding big A first. So since we're solving for an angle, let's put the formula as the sine of big A on the top and the 189.6 on the bottom. It just saves you a step. If you want to see how it saves you a step, write it the way that we did the last couple of problems and see how it's saving you a step. This is sine of 113.72 degrees. And we're dividing by 243.8. So now all I need to do is multiply by 189.6 in order to get my sine of A by itself. 189.6 sine of 113.72 degrees and dividing that by 243.8. All right, let's put that in. 189.6 times the sine of 113.72, close the parentheses, divided by 243.8. And we get the sine of A is approximately 0.71. Okay, we still need to solve for A, but I want you to stop and think about this. The sine of A is 0.71 in two different places. If you're thinking about your unit circle here, okay, go ahead and do the inverse sine of that number that we just got. We're going to get about 45.40 degrees. So A is about 45.40 degrees at two decimal places, because over here the given degree was given to two decimal places. But that's not the only place here where your angle is 45.4, the sine of it is 0.71. You also have an angle over here. Okay, this angle has a sine of 0.71. So how do you find that? Well, we take the 180 and subtract off that 45.4. So 180, we're subtracting off that number there, and that's 134.6. Okay, so you could also have A being 134.60 degrees. But stop. The given angle was 113.72 degrees. Even though you have another possibility here as far as angles go, there's no way you could have a triangle with both of these angles in it, because the sum of all three angles is 180 degrees. So we know for this time we are only going to have this one possibility of the 45.40 degrees. All right, now we need to find the little c. So little c is going to be over the sine of big C is 180 minus the 45.4 minus the 113.72, and we get 20.88. So 20.88 degrees. Let's put that there. 20.88 degrees. My little a was 45.40 degrees. So we'll make this equal to the b that was given. That's the safest way to go to avoid round off error. 243.8 over the sine of 113.72 degrees. And I'm just going to multiply both sides by the sine of 20.88 degrees. So my little c is 243 times the sine of 20.88, and we're dividing all of that by the sine of 113.7. Oops. So we'll go ahead and put this into the calculator. We've got 243.8, and we're multiplying that by the sine of this 20 point, make sure and grab that angle there instead of rounding it off to 20.88 degrees. And we're dividing by the sine of 113.72 that was given. So we don't have to go up and grab anything, you just take it from the given information. And I get about 94.9. It looks like our sides are being rounded to the tenths place, and the label is yards. Okay, so we have A, we have our big A, we have our little c, and we have our big C. Those are the parts that we're missing. Make sure and either list them out to the side and put a box around it, or just put boxes around your answers for each of those. All right, let's see what we can do with this one. I've got an angle B and sides A and B. Again, the scale doesn't matter all that much. This is B, 48.2 degrees. Little b is across from it at 697 centimeters. And this is big A, so this will be our little a of 890. And this will be big C and little c. We are missing our big C, our little c, and our big A. Since we have big B and little b and little a, let's go ahead and solve for big A first. So since we're solving for big A, we'll put the formula this way, save us a step. And this will be over here, sine of 48.2 degrees. And that's over 697. So I'm going to get sine of A is approximately 890 times the sine of 48.2, divide by 697, and I get about 0.95. Okay, now we can take the inverse sine to figure out what big A is. And so big A is about 72 degrees. All right, 72 degrees. Actually, we'll go ahead and round to 1 decimal place since they've given the angles to 1 decimal place. All right, but if you think about it, let's look at this again. Where is the sine of an angle 0.95? It's right here at your 72.2 degrees, but you also have this angle over here. So how do we get that? We take 180, we subtract off the 72.2 degrees. Take 180, subtract off the 72.2 degrees, and we get 107. If you take that 107 and add the 48.2, which was the only angle given, we still have enough for angle C. So this is a case where we have two triangles. Okay, so we have to label this as A sub 1, C sub 1, big C sub 1. And we'll have a big C sub 2, a little c sub 2, and a big A sub 2. Big A sub 2 is about 107.8 degrees. And now that we know A sub 1, we could take 180, we can subtract 48.2 that was given, and we can subtract our 72.2 that we found for A sub 1, and that gives us a C sub 1 of about 59.6 degrees. Now we need to find our C sub 2. That's 180 minus the 48.2 that was given, and minus the 107.8 that we found. So if we're talking this triangle, then we've got about 23, well, we'll go 24.0 degrees. All right, now we need to find little c sub 1 and little c sub 2. For little c sub 1, we'll be using this measurement. Let's go ahead and use the b, big B and little b that was given so we don't have round off error. And since we're finding little c, let's put little c on top over the sine of 59.6. Remember to use the one that's in your calculator, not rounded. And that's equal to 697 over the sine of 48.2 degrees. So C is approximately, we'll do 697 times the sine of 59.6, and we're dividing by the sine of 48.2, and I get about 807. So C sub 1 is about 807 centimeters. And now we have to do the same thing for C sub 2. Go and write that as C sub 1. So C sub 2, if big C was 24.0 degrees, is equal to, the rest is the same, that was the given, it's set, it's not going to change. So C sub 2, I need to take 697, multiply it by the sine of, use the one that's in your calculator, the 23.9568784, and divide it by the sine of 48.2. And I'll get about 380. So C sub 2 is 380 centimeters. All right, some people like to write out two triangles. I actually like to write out two triangles. I just don't have enough screen space in order to do that. So you might practice it with writing out the two triangles. Once you realize there's going to be two triangles, it helps you keep all the information organized. All right, this one here, we have big C and little c. So big C, 68.5 degrees, and little c is 258 centimeters. We have little b is 386 centimeters. This will be big B, this will be big A, and this will be little a. And we'll see how we go with this one. Let's find B first, since we have little b and we have big C and little c. So sine of B over 386 is equal to sine of 68.5 degrees over 258. And so I know sine of B is approximately 386 times the sine of 68.5 degrees divided by 258, and I get 1.39, and that cannot be. The sine of an angle is going to be between -1 and 1, so we're not going to have that. This means we have no triangles. Okay, so there you have it. A one triangle, two triangles, or no triangles with the ambiguous case. All right. Here's a word problem. You're not normally going to solve a triangle when you're using this in real life. You want a specific measurement, and that's the only one that you really care about. So this is a canyon here, and the person is standing over here. Okay, they're standing over here, and they look across and they see an easily identifiable landmark that they could walk a while and still look over there and say, hey, that's the spot I was looking at. So she knows her path is this way along that 582 yards, so she sights the angle at 32 degrees 50 minutes. She walks 582 yards this way, and then she sights again, and inside that angle from the path that she just walked to the landmark is 102 degrees 20 minutes. So we need to find this distance across the canyon from the first place that she was standing there at T to the landmark at S. What is the distance of TS? All right, so we don't necessarily want to know what this angle is, but we're going to need it to be able to use it with this 582 yards. So we're going to take 180 degrees, and we're going to subtract 102 and subtract 20 sixtieths, and subtract 32 and subtract 50 sixtieths, or you can just do 5/6, that's fine. And we get about 44.83 degrees. We'll just keep it as a decimal measurement, decimal degree, 44.83 degrees. All right, now that we have that and we have the 582 yards, we can set this up. My distance that I need, x, over the sine of 102 degrees 20 minutes is going to be equal to 582 over the sine of 44.83 degrees. So we will take this, multiply both sides by the sine of 102 degrees 20 minutes. So 582 times the sine of 102 degrees and 20 sixtieths, and we are dividing that by the sine of 44. Oh, we don't want to put 44.83. We need to actually go up and use that so we don't have that round off error, and we get about 806.4, and that is in yards. Okay, so yards. All right, We don't care about getting this other measurement over here. The only thing that we needed to find was that distance across. We got the 44.83 degrees only because we needed it to make our proportion with the law of sines. All right, area of a side angle side triangle. So if you have some case where as you're reading around the triangle that you are given a side, you're given the next angle, and you're given the next side. That's what it means to be a side angle side triangle. Then the area of that triangle equals half the product of the length of two sides times the sine of their included angle. So we're going to use that with this here. Find the area of the triangle. And let's go ahead and just write this out over here so we kind of have oriented to everything. Big C is 142.7 degrees. This would be little c. This would be, we'll call this big A. So this is little a at 21.9. This would be big B. So little b is 24.6. And there we go. We see the side angle side triangle. It's an using the generic form of that formula, the area of the triangle is going to be 1/2 of the sides multiplied together times the sine of their included angle. This is the angle that those two sides make, their included angle. So it's actually quite quick. We'll say the area is 1/2 times A times B and times the sine of their included angle, 142.7 degrees. So we'll do this, 0.5 times 21.9 times 24.6 times the sine of 142.7. Make sure I've got everything typed in there correctly. Yeah. Enter, and we get an area. They put this as a script A so you don't confuse it with big A being an angle, but A is approximately 163, and that's going to be kilometers squared. And that does it for your 8.1. You've got an example of everything that you need to be able to figure out your homework. So have at it and have a great day.